So very good afternoon to you. You can see I carry on where we left last week. And if you click the data view here in the bottom left-hand yellow box, you can see the data, and you can see that we have the revenue variable, the price to earning ratio, the company's operating profit ratio, the market's operating profit, the average market's operating profit ratio. DE is debt to equity. See what, in the normal circumstances, in the Word file, for example, I would write DE ratio as D/E, but SPSS doesn't like these extra symbols. So I rather keep them, and we never have the space between the variables. So for example, if I try to say market dot or space OPR, it will never like. So it should be one condensed. Innovativeness, it's a binary variable. You can see the companies do innovativeness or they don't do any innovativeness. Which company is this? There should be one firm here. You can see it is firm number 5 doesn't do any innovativeness. And then we have the financial stock return, the firm stock return, the company's stock return. And then we have the index stock return. These are the extra variables. I delete them, but I'll come back to them afterwards. And this is the company stock return, and this is the index stock return. Because all these companies are from United Kingdom. They are listed in the London Stock Exchange. Therefore, I took the market index as FTSE 100 return, because all the companies which I have chosen here, they are in the top league. So I thought that maybe I should pick up the FTSE 100 index. If you click this one, you can see the variable view, so that we can switch between data view and the variable view. And a quick recap, you can see the nature of these variables now. They're labeled here. They all are numeric values, no qualitative, no text, all numeric values. Width, it comes by default. Decimals, I always set. I believe that sometimes the numbers are small, so depending upon I have to get familiar with the variables, but normally I prefer 3, 4, 5 decimal places, and make sure that all these variables are numeric. String variables or some extra other kind of variables, they could be trouble. So for example, if you are having some comma, dot, scientific, no. In statistics, in econometrics, we normally deal with the numeric values, and there we go. So we stick with the numeric values. So we see that we haven't done any violation here. Everything seems to be fine in terms of our input variables. Okay, now I go to the data view. I go to my these variables. Well, I can delete them because I was just playing before we met, so I can get rid of them. So how to remove them? Well, clear. Yeah, so I just want to clear them. We can come back to them. So I clear these unnecessary variables. They can cause unnecessary confusion. So let's start from very basics. So we have the variables now. Now imagine we study the literature review, and we find that the companies, the firm return depends on some factors. I hope if you know a little bit of regression, you find that there's a cause and effect relationship. So for example, from the literature, we make a conclusion that the firm return, which means the company's stock return, the firm stock return depends on, so function of revenue, the company's revenue, depends on P to E ratio, the price to earnings ratio, depends on, do you know any other variable? Yeah, there was one, firm operating profit ratio, firm operating profit ratio. It also depends upon the market, average market operating ratio, operating profit ratio. Then which was the other variable? Innovativeness and the market index variable. Now the question here is, what made me choose those variables? Well, I studied literature, I studied different articles, I studied some textbooks, and textbook says that if you want to find out which factors have an impact on the company's stock return, then these are the strong variables. So that's why we call firm return as a dependent variable. We call it dependent variable Y, and we call these right side variables as independent variables. So I can say that here my company return is depending upon beta 1, X1. And who's X1 here? Revenue. Plus the next variable, beta 2. Betas will measure the impact. Beta 2, X2. And who's X2 here? The price to earnings ratio. Are you getting me? So from the literature, I'm making my model. And my model is the firm stock return symbolized by Y depend upon revenue, call it X1. So let's call all of these right side variables as independent variables, and we write them with the letter X, X1, X2, X3. We have 1, 2, 3, 4, 5, 6 independent variables. So it means that I can write down up to beta 3, X3, beta 4, X4, beta 5, X5, beta 6, X6. Do we have 1, 2, 3, 4, 5, 6? So all the variables are included. Now the question is that you can understand that Y is firm stock return, and all of the variables are X1, X2, X3. What are these betas, B1, B2? Well, they are measure of the impact. For example, beta 1 measures how much X1 influence Y. Beta 2 or B2 measures how much X2 affects Y. And who's X2 here? How much P to E ratio, price to earning ratio, have an impact on the stock return. Beta 6 measures how much the market index return have an impact on the, yeah. So these betas are the quantities of the impact, okay? Market index return, actually, it's not a variable. So we have all these 6 variables here. So can you find out that, remember your dependent variable at one point of time can only be 1, but your independent variable can be many. So for example, if you have only one independent variable, we call it simple linear regression. But because we have many variables, so I would say multivariate analysis. So what we are going to do now is basically this analysis which we will perform is multivariate ordinary least square method. Okay, so it's like a multiple, so it's MOL, this method we are applying here. But the basic idea is that we are having multiple variables. So for example, I can say that in Uvascula, if I want to find the crime rate depends on what? Crime rate should depend on how many cops we have in the city. When I said depend upon, it means that it could be negative relationship also. So more police means less crime. It should also depend on level of education in the city. It should also depend upon the level of creative or recreation activities. People are having fun, they have gym, they have all the social facilities. Why should they commit crime? It should also depend upon how well the city council is treating its people. I mean, in terms of, those, what do you call as a allowances and things like that. So there'll be many variables which have an impact on certain phenomenon. In this case, our phenomenon is the company's stock return. So basically, we are analyzing about 100 companies in the UK. What factors determine the stock return of each company? But remember, these variables we choose from the literature review. That's why the literature review is very important. Otherwise, we don't pick them randomly, okay? So what we do now, but do you have any questions so far? So why is it dependent variable? The synonyms of dependent variable is called explained variable or predicted variable. The synonyms of independent variables are explanatory variables or predicting variables. So just in case you come across these extra words, don't get confused. They are same, basically. All right, so this is what we have so far. This is coming from the literature, these information, revenue, P2E, and then we convert our theories into a empirical model. What you see now, Y, depending upon A, the intercept, beta 2x2, beta 3x3, this is our econometric model now. We have modeled our variables to be empirically analyzed. Yeah? Now we go back to our SPSS space. So now we know that who is our dependent variable and who is our independent variable. Folks, can you see the screen, SPSS now? Can you see it?
Yes, we can see this.
Very good. Okay, now, once again, I told you last week also that most of the times we will be using analysis, the analyze thing. We go to analyze, yeah, right? Last week, we studied descriptive and correlation, if you remember. Now, we will do regression. Can you see here? Have a look here. Analyze, regression, and linear regression. So, analyze, regression, linear regression. Three things. So, the tab, analyze, then go to regression. Because I'm not doing, we can do the non-linear regression as well, but that's not what I'm going to do now. I'm only going to do the linear regression, the basic regression. We click here. Can you see here? There's a one, the two boxes here. The label is dependent variable. And then here, the label is independent variable. Now see that it says independent bracket S. It means that SPSS knows that there can be more than one independent variable. But here, there's no S here in case of dependent, because SPSS knows that at the most, there can be one dependent variable. Let's bring it back. So who is our, may I ask you now, in our model, who should be our dependent variable? stock return. So what I do, the firm stock return, we call it dependent. And then all the variables are independent variables. So I can take them one by one if you want. But if I take all the variables, then I can select them. And in the one go, we take it here. So now we know that this is our dependent variable, and these are our independent variables. Now we make some minor changes. We go to statistics. Statistics, you can see here, we want estimates. Estimates are, by the way, B1, B2, B3. These are estimates, okay? Remember, Y is equal to B1, X1, B2, X2. So all these B's, B1, B2, they are called estimates. The confidence interval, how much I should take? Any idea? How much confidence interval I should take? And we have done it before. 90. You know why? Because the maximum level of significance is 10%, which means we can accept the 10% chance factor, but we want to be 90% confident that our results are significant, meaningful. So that's why we choose 90%. And if you go to SPSS and it shows 95, for example, make it 90. You can do it. We don't do anything here, I think. Model fit is fine. Descriptive is okay. Descriptives we have done last week, but it will do again automatically, default setting. Collinearity diagnostic I would take. I'll let you know what it means basically. But first of all, I will take it. Collinearity diagnostic. And one more thing I would pick up is Durbin-Watson test. Durbin-Watson test. I will explain it again, what it means basically. So you can have a look. Estimate is must. Confidence interval is must. Descriptive, you may choose. Model fit, you may choose. And I think collinearity and Durbin-Watson is something which kinda must choose. Okay. When you have all of them, then just go for continue. Okay. Plots, I don't want to plot anything. Save, maybe yes. I want to find, I have the actual value of dependent variable, but I also want to find the estimated value of dependent variable. So here I take predicted value. Remember, your predicted variable is Y. And we have the actual stock return. We have the real values of Y. But it's not a bad idea to find the estimates also. So I click this. I think I need nothing else. And once I have it, stepwise is normal setting, but anyways. And then we click OK. And guess what we get? The title is regression. The title of the output is regression.
Please share the output file. We can
I will.
see the data file.
All right. Thanks for letting me know. So the output title is regression. And you can see that the firm stock return, the mean value, and I think we have done it before, so I will not spend time. Correlation comes again here, Pearson's correlation. Significance. Okay, now I take you to the model summary here. I want you to pay attention to this value, model summary R square. R square. R square is 0.59. 0.059. If I change 0.059 to percentage, it becomes 5.9%. Now, this 5.9% means, listen carefully, all the variables put together, all the independent variables put together. And who are those independent variables? X1, X2, X3, X4, X5, X6. So all, remember we have 6 independent variables, X1, X2, X3, X4. All of them put together are explaining 5.9 percentage changes in your dependent variable, which is the firm stock return. I repeat, all the independent variables, which are revenue, price to earning ratio, the company's operating profit ratio, the market's operating profit ratio, the innovativeness, and the index return, which was FTSE 100. All of them together are only showing 5.9% movement in your dependent variable, which is the firm stock return. It means if 5.9% movement is explained, it means that there is 94.1% movement which is not explained by these variables. Make sense? If 5.9% change in your dependent variable is explained by these 6 independent variables, and how much is it's explained? 5.9%. So what is 100 minus 5.9? 94.1%. It means that 94% one movement is somewhere else. Maybe we are missing some variables. Maybe we have taken some useless variables. Maybe our model is not linear but non-linear. So it means that, but remember, this is not a crime. Don't think that if the explanatory power is low, it's a crime. No. Wait a sec. It's just for your information that there are 90. It means that the company stock return in Britain, there are so many variables which are not included in our model. Perhaps we did not study good literature. Hence, we didn't know who are the real variables. So there are many ways of thinking this thing. But in this workshop, my idea is only to make interpretation of these numbers in sentences. And in sentences, I can find out that there is 5.9% change movement in your dependent variable, which has been explained by all these 6 variables. It means the remaining movement, 94.1%, is somewhere else. The second point where I would draw your attention is Durbin-Watson. I can explain it. Your Durbin-Watson test should be neither more than 2.25 nor less than 1.75. Do you get my point? 2 is in the middle. On the one side of 2, we have 1.75. And on the other side of 2, we have 2.25. So 25% on around 2. Your Durbin-Watson test should be between 1.75 to 2.25. If it is not, it means that there is a lot of error related in the variables. So it means that there is the error term is very strong in the variable. I wish I had a econometric course where I could teach you what these words mean in theory also. But what you need to remember, because you are not studying econometrics now, You are studying SPSS as a practitioner. And for a practitioner point of view, I can tell you that the Durbin-Watson test must be between 1.75 to 2.25. If less than 1.75 or if more than 2.25, you have to be worried. There should be some reason to be worried. And then we find some solution. But anyways, that's a different story. And then we come back to F. We have R square, which shows the movement. The question is this movement significant or not? This we get from F test. And the F test is significant at how many, what percentage? 10%. We can say that our R square is genuinely acceptable, reliable. We can trust our R square. This is R square value, but is this R square significant or not? It depends upon this value. If the F test is significant, for example, just imagine, I don't much care about the value of F. What I care is it significant or not? If it was, if this level was, if the significance level was 0. Or 0.015, it means that your R square is not significant. It's not acceptable. It means our model has some problems, but fortunately we are almost at the bottom line, 10%, so we can accept it. And now you can see here that this is very important. Our A, do you remember when I drew this, wait a sec. Do you remember? Well, I can show you again. When we had this whiteboard, there was this term called A. Yeah? Can you see A? A is a constant term. And when I go back to the output, I find that there is a word called constant. Can you see here constant? This is your A. This is your A. And look at here. FTSE 100 return. The index return. Index return is the only significant variable. Can you see here? Remember, we had 6 independent variables. Where are the others? They disappeared because they were not significant. And you can see here that FTSE 100 return is the only variable which is significant. This is the value of beta, B. So I can call it B6. Remember, in our model, the index return was X6. Yeah, X6 was our value. And this is the value of B, B6. The question is it significant or not? Yes, it is 10% significant. So we can say that among all the 6 independent variables, among all the independent variables, FTSE 100 return is the only significant variable. And the question is the impact positive or negative? Look at the sign of beta. Is it positive? It means that the index stock return positively impact the firm stock return, and this finding is true with 90% level of confidence. With 90% of confidence, I can say that the index stock return positively, it could be negative sign also, but in this case it's positive, positively have an impact on the firm stock return. Yeah. Now, should we assume that all other 5 variables are rubbish, junk, useless? Well, apparently yes, but it's not a bad idea to have another view. Look, there's a list of excluded variable. Excluded variables. The variables which we exclude. Yeah, but see what? Before you finally reject them, it's not a bad idea to have a look at them again. And you can see a look. Have a look at this. Look at this table, this column, SIG. 89 revenue have a confidence level 11%. No, no way. We can never accept revenue. No, 82.5. I mean, but there's one variable, D to E, which somehow got missed. Should we accept it or not, by the way? Yes. So even sometime you can find a diamond in the rough sometimes. And we found that even though apparently FTSE 100 is the significant variable, but when we have a second look, maybe SPSS somehow missed it out. We can say that debt to equity ratio, D to E ratio, is also a significant variable. And how do I find it? Because it is less than 10%. It's less than 0.1, 0.10 basically, you know. But all other are unacceptable. Innovativeness have no role to play. Market operating ratio have no role to play. The company's operating profit ratio have no role to play. Price to earning ratio have no role to play. Revenue has no role to play. So out of all these variables, I could find two variables which are meaningful. One is that debt to equity ratio. And what is debt to equity ratio, by the way? How firms get financed. The way firm gets financed have an impact on the company's stock return. And what is the ratio here? Debt to equity ratio. It means more debt you have. So we have a conclusion now. More debt the company has for a given amount of equity, the company's stock return goes up. Theory can say otherwise. So here we can go against the theory sometimes. On the other hand, when the index goes up, the company's return goes up. So we could find two important variables where which are good variables. So we could find two important variables in this. There is nothing else I need to show you except that there is a VIF, which VIF basically is the inflation factor. I would say that if it is about less than 5, this factor, this just remember when we go for, in many ways, I compare SPSS output as our medical test. When a doctor recommends us to go to the hospital and go for some medical test and they take a drop of blood, they test certain conditions, but when we get the medical report, there's so many pages of results, and many of them we don't need, basically. So in SPSS output also, there are many things that we don't need to even look at. But I would look at VIF, which is a variation inflation factor, which means that, which means that how much correlated your independent variables are. We want, ideally, we want that each of the independent variable should be highly correlated with a dependent variable. But if our independent variables are correlated with one another, that's not a good thing. That's not a good thing. And this value inflation factor is telling us this thing. If it is about 5, I think up to 5, it's fine, 4, 5, and less is better, less the better. And we can see here that it's close to 1. It's fantastic. So the correlation is very low, which is good. So that is what we need to find out here. So once again, I repeat, what you should look at or what you shouldn't look at, that when you have the SPSS output, check if your R square is, how much is your R square, check Your Durbin-Watson test should be between 1.75, 2.25. We are in the safe zone, it's fine. Then check if your F test is significant, which is 10%, we accept it. And then go to the coefficients. This is your beta, and this is a significant level, okay? But it's not a bad idea to have a look at the remaining variable. There could be some surprise for us as well. And the surprise is that even though these variables are excluded, but there's one variable which is significant because it's less than 10%. And that is debt to equity ratio. So don't outrightly reject the excluded variables. You might find some good surprise. So out of 6 or 7 variables we chose, there are 2 variables which have a strong impact on the company's stock return. And I don't think you need to see anything else in this output. No, just do as much as I said. That's enough. So this is how we perform the multivariate regression analysis in SPSS. Okay, so basically, I need to write it down. I want to show you, remember that the value of your, how much is the value of your FTSE return? FTSE 100 return, your beta is plus 0.939. And your T value, which we just take customary 2.612. And the significant level is 10%. And who else is your significant variable? The other variable significant is D to E. And the value of beta is 1.62. And the level of significance, it's positive. And the level of significance is basically 8%. So yeah, so once I have these variables, I can go back to my the whiteboard that we created. So we could say that hey, the firm stock return, which is Y variable, is equal to which variable I was using for D to E ratio? Did I actually? I didn't write it. DE. So let's call it maybe, yeah, so let's call it B7. Yeah. Anyways, so we can say that we have A will always be there, plus we have a variable FTSE 100, and this is 0.939, 0.939, and this is FTSE 100. Of course, I explained it in terms of X. It could be X6 or X7, whatever. And then we have one more variable, which is significant. And this is 0.162. And this was our D to E ratio. So these are our 2 variables which come victorious, which come as significant variables among all of them. Yeah. So these are the important variables. The rest all are rejected variables. We don't take them. They are not significant. They may have a random effect, but we don't really care about it. So that's what we get from this regression analysis. Do you understand it now? You get some idea? Should I do it all over again, or are you fine? If you want, I can repeat the whole thing once more. Do you want it? Or are you okay with it? Yes, folks, do you have anything to comment on?
You can watch again the recording.
Huh?
You can watch again the recording.
Yeah, it's getting recorded, yeah. Yeah, so you can watch it and see if there's anything. Okay, so this is how we, and this is not just about finance, it's about, it could be, you can use SPSS, this regression analysis, in any field. In psychology, as I gave you one example of crime rate in the city, depending upon how many variables, you can say, even in marketing, you can say that what factors affect the company's spending on advertisement. So advertisement expenditure of companies depend on what variables. In agriculture, you can study the output of potatoes depending upon rainfall, depending upon the temperature, depending upon the quality of soil, depending upon if there is a too much or too less of snow, wind. It depends on some certain insects or some if there is some kind of we can get some germs, some insects, can they have an impact? So in every field you can apply this analysis. There's always some. In psychology, you can find people's behavior. You observe the behavior of 100 person in the city, and you find what factors why people become aggressive. Well, it could depend upon the time of the day. It could depend on their income level. It could depend upon if they're unemployed. It could depend on their family background, and likewise. So you find every time, every phenomenon, there's a cause and effect relationship. There's always one cause variable and one impact variable. In fact, the cause variables can be more than one. That's why we took, in this case, we took 7. I think I forgot to write 1. There are 7 independent variables. So there are 7 factors. Okay. So this is about the multivariate, ordinary, least square regression, basically. Yeah. If I had one independent variable, only one x, it would have been called not multivariate, but bivariate. You know, bi stands for two variables, one dependent, one independent. But if you have more than one independent variable, then we call it multivariate regression. All right, so we take a short break now. And then afterwards, we study another technique, which is quite similar to regression. Should resume. Now I guess everybody's back. The next topic which I want to discuss with you is called principal component analysis. I think I should first of all discuss the theory of principal component analysis. We also call it PCA. Seher and your team, can you watch his screen being shared with you?
We can see the whiteboard.
Yeah, I'm only sharing
Yes.
whiteboard.
Yes, we can see that.
Okay. So the principal component analysis, before I discuss more about it, we need to go and see a little bit of background of principal component analysis. Imagine, and I think I should give you some non-financial example, then it will be better. Whiteboard, sorry. Yeah, principal component analysis. Just imagine, and as I said, that sometimes it's easy to study finance with the non-financial examples. So let's find some non-financial example. Let's say we survey 1,000 people in the city of Uvascula, and when we survey them, we find an overall value that are you happy or unhappy in the city. So we take an index value and we ask people, finally we ask people that, hey, are you guys happy or unhappy? And they give us some value and we write it down, and we survey 1,000 people. And then we write it down here that the happiness of people and when we ask them on question that are you happy or unhappy, and they give some responses on a scale of 1 to 5, extremely happy, extremely unhappy, moderately happy, highly unhappy, etc. And we find, then we ask them some more questions that because we want to find out what determined happiness of people in the city of Uvascula. So let's call it happiness index. And then we find out that the variables which can affect happiness are number of hospitals in the city. More hospitals, more health, better health, more happiness. Modern machinery in hospitals, machinery, equipment, whatever you call modern equipment. Number of nurses available at your number of nurses. Distance of hospital from home. So we ask them several questions and they're replying us. And then we ask them, what about the infrastructure in the city which makes you happy? I mean, road length, more roads in the city makes you happier. Your transportation becomes easy. Frequency of buses. Obviously, if you have to wait for a long time on a snowy night, you will not be happy about it. Cost of public transport. And then we ask them more questions. And then we ask them, do you feel safe in the city? Do you think that the crime rate is more? Do you think that the robberies are increasing? If you leave home and when you come back, you always have a kind of fear in your mind that when you come back, somebody would have robbed your apartment. Or number of, for example, crime-related deaths, for example. When people read about the news that how many people have died in, in stabbing and these kind of things, that also determine people's happiness. Are you happy? Are you scared? Or what? And then we ask them about some general well-being, that how about the number of schools in the city? Teacher number for every 100 students. How many teachers we have for every 100 students? Higher education facilities. Etc., etc. If you look at this example, I deliberately chose this example actually. In many ways, this example looks like this thing. The firm stock return depend on revenue and firm operating profit. So there are variables which affect the firm stock return. Same way, these are the variables: number of hospitals, modern equipment in hospitals, number of nurses, distance of hospital from your home, etc., etc. These all are variables. These all are variables. But sometimes you find that these variables are too many, isn't it? Can we condense them? Can we somehow, because it seems that if you look at the first set of variables, the number of hospitals, modern equipment in the Kula, number of nurses, distance from hospital from your home, are they all talking about the health factors? Can you make out? Can I combine that from here to here? They all are basically the health variables, health related variables, isn't it? Are you with me? How many variables they are? May I know? 1, 2, 3, and 4. 4 variables. But what is the construct? What is the construct? What is the phenomenon? Health. Is there any way that I can condense all these 4 variables into one construct, one phenomenon, and call it health construct or health factor? Look at the second variable, set of variables: road length, frequency of buses, cost of public transport. Do you find any similarity between these 3 variables? Huh? You do. Are they all related with some kind of transportation? So it means there are 3 variables of transportation. But is there any way that we can condense them into one construct or one phenomenon called transportation? You with me? Look at the third set of variables: crime rate, robbery, crime related deaths. Can I put all these 3 variables into one construct called general safety, or safety construct, or safety factor? Can I? And then look at the last factor: number of schools, teachers for every 100 students, higher education facilities, number of schools, etc., etc. 3 variables are talking about what? Which construct? Education. Well said. So sometimes we are interested that is any way that we do not repeat unnecessarily similar, not same, similar variables, and try to put them into one construct. And instead of calling it variable, call it a construct or call it a factor, like a health factor, which combines everything about health. Education factor, which combines basically every variable about health, and so on and so forth. If you are thinking on these lines, you are thinking about principal component analysis, where we are filtering out too many variables, and we are also filtering out unnecessary variables. You get the idea or not? Yeah. Look at this, our original question. Now this was a kind of cooked up example, but look at this variable: revenue, firm operating profit ratio, market profit ratio. When I see the revenue, now please be careful, I didn't write them in the order, so you have to look at to get the idea. If you look at revenue, the firm operating profit ratio and the market operating profit ratio, are they not accounting variables, accounting performance variables? So had I used principal component analysis, I could have combined them into one variable as accounting performance variables, isn't it? Because revenue you see from accounting books, the firm operating profit ratio you see from accounting books, and obviously when you see for all the companies, the whole market operating profit ratio, that also come from the accounting books basically. So I had 3 accounting performance variables. Similarly, if you look at the if you look at the P to E ratio, price to earnings ratio, and you look at the market index return, they are talking about the company's performance in the stock market. So there are two variables, P to E. P means the stock price value and E means the earnings per share. But because it involves P, the stock price, and then the market index return. So can we say that P to E and market index return could be labeled as or clubbed as the market performance variable? And same way, if you look at the innovativeness and debt to equity ratio, these are basically company's leadership or organizational characteristic. The company, how innovative the company is, it depends upon the company's organization, decision making, the board of directors basically. How much company borrow and how much company raise money via equity, it also depends upon the company's organizational structure. So could I combine D to E and innovativeness as a organizational construct of the company? So basically, I could have clubbed 7 variables into 3 factors. So then my model would have been, firm stock return depends on accounting performance, stock market performance, and organizational phenomenon. Look, I could have reduced my 7 variables into 3 factors. When I do this condensation, when I do this condensing or clubbing of the too many variables into phenomenon, into construct, then we use the principal component analysis. Is the theory clear about it? You get the idea? Okay. Now once this idea is clear, now we go to it means that when I do the next SPSS exercise, I would be having my 3 variables as the deep independent variables. Anyways, any questions from my friends online watching? If you understand the theory of principal component analysis, then everything is so simple because it's so mechanical. Then you just have to remember the commands. That's it. You don't even have to remember it actually because there's no exam like that. So you can ask me anytime or you can watch from the video. But main thing is that you should understand the difference between regression and principal component analysis. In regression, we take variables, independent variables. In PCA, we take construct. A construct could be a combination of many variables because they're so similar. They're so close to each other. All right. If you all good, then I take you back to SPSS. Data, basically. Seher, can you guys see the screen?
Yes, we can see this.
Okay, all right. Now the question is, yes, sir.
The main difference between the regression and the other one. The main difference.
In the regression, we take individual variable which you think can affect. But sometimes these variables are so much similar that we think that is it really worth to take 2 or 3 variables separately? Why don't we combine them and make a phenomenon? You see what? If I want to test your intelligence, right? if I want to see how intelligent you are in finance, I can give you a test, written test, yeah? I can give you an assignment. So I get your assignment marks, I get your exam marks, I see your general behavior in the class, how well you perform. So I put my mental marking, right? So why I'm taking 3 variables to judge your intelligence in finance? Why don't I combine them 3 into 1? Are you with me? So when we do this thing, then we are talking about the component analysis. Okay, see, your marks in finance in the written test is a variable, right? Your class performance is a variable. Your general activeness in the class, activity level in the class is a variable. But when I combine these 3 variables and I label it intelligence, right, then things become more structured, more organized. That's the difference between the two, basically. Okay, all right. We go to analyze as before. And here you can see there's a thing. Now you need to remember that now we don't click descriptive, we don't click correlation, we don't click regression, we click dimension reduction. Okay, so we go to dimension reduction and then we go to factor. So look, the 3 yellows thing, you need to remember that. Analyze is a starting point, dimension reduction is the second point, and then the factor is the third point. Okay, and once we click it, we go in the activity area. Yeah. Yeah. And see, I think I forgot to mention about the unstandardized, but I'll come back to it. You can see that except the dependent variable, all the independent variable which we used in the regression are here. Can you see them already? Yeah. How does SPSS know it? Because before doing this thing, I was doing regression. And in the regression, I took independent variables, right? So all of them appear as factors here now. So that's why. So SPSS knows that what we have been doing before. Now, I repeat, this is very important. Even by mistake, your dependent variable should not be here. Only remember, we are combining independent variables into constructs, not the dependent variable. So keep it out. By chance, it's out already. So if the firm stock return is here, send it back. Send it back. Because the firm stock return is dependent variable. We only want to make factors out of independent variables. All right. As usual, we click descriptives, right? In descriptive, we have the univariate. It's fine. And one more thing we click here is KMO. Don't ask me what it is, but just remember it. Continue. And then we go to extraction. In the extraction, you can see I'm using principal components. I use correlation matrix and I use a plot. Plot would show that how it looks when you draw it on the picture. And very important thing, I wrote here 3. You know why I wrote 3 here? Huh? Do you know why I wrote 3 here? Okay, I give you 30 seconds to, huh? There are 3 categories, three factors. Which are those? Accounting performance, stock market performance, and the organizational construct. Yeah. In accounting performance, you have revenue, you have the firm operating profit, you have the market operating profit. In the stock market performance, you have the stock return, the index return, and you have the price to earnings ratio. In the organizational construct, you have innovativeness and debt to equity ratio. Yes. Well, we will see. We will see. We'll see. But do you know this? What this 3 means? Yeah, 3 constructs. Continue. Rotation. We always take very max rotated solution. So don't make any change here. Basically, just keep it the way it is. Scores. Nothing to be changed. Options. Options. Sort by size, and I don't want to take any value less than 0.3. So that's why this is like a custom. There's no rule for it, but we never like to take any output result less than 0.3. So I write it 0.3, that hey, absolute value below 0.3 is unaccepted. Look, coefficient display format, absolute value below 0.3 I don't like. So this is something which because before I came to this lecture I was playing with it, so these appear automatically, but you guys should remember that don't take any value less than 0.3. 0.3 is like it's a custom. There's no scientific rule for it, but it's a custom that we don't take less than 0.3. And continue. Once again, descriptive, we take univariate, we take KMO, click OK, then next thing is extraction. Take principal component and the fixed factors. We have 3 factors. Continue, rotation, varimax, and rotate solution, nothing else. Continue, scores. I don't think we did anything here. And the options, we have sorted by size and suppress the small value below 0.3. Any value below 0.3, suppress it. So this is something we do. And afterward, we are ready to rock and we click OK. And you can see here, the factor analysis is done, basically.
Please clear the output file.
Yes, yeah, I will. Thanks, Seher. Can you see here title, factor analysis, you guys?
Yes, now we can see.
Very good. So now the factor analysis is done, basically. Now the question is how to make interpretation of it. Look, the first result, which is really cool, is that look at our level of significance. How much is this? Almost 0%. So we can say with nearly 100% confidence that our initial results are significant. It's really good. And then we go on. The plot we can discuss afterwards. The key thing is this. This is very important matrix. It's called rotated component matrix. And see, operating profit, look at them. Do you know what is this? 1, 2, and 3? 1, 2, and 3. These are 3 components, constructs, factors. And can you see that all these variables are loading? So they are running to 3 factors. Yeah? Look, the operating profit ratio, the price to earning ratio, and the market operating profit ratio are running to the first construct. And what was, by the way, our first construct? Accounting performance. Second construct, the market operating profit ratio also goes to second and third construct. Innovativeness goes to the second construct. The D to E goes to the third, the second construct, and the revenue goes to the second construct. So, and same way, the FTSE return goes to the third construct, and the market operating profit ratio also goes to third construct. But see what? First of all, the rule: any variable which is touching more than one construct, we straight away ignore it. We filter it out. We cancel it out. For example, the market operating profit return, can you see, is touching construct 1, construct 2, construct 3? No, we don't take it. So it means that for the further analysis, you would never consider market operating profit ratio as a important variable. So we have got rid of one unnecessary variable. And the name of this variable is market operating profit ratio. With me? Yes or no? The market operating profit ratio is ignored. We will not study it in the future because it's touching more than one construct. Same way, I would totally ignore revenue for the future analysis because it's touching construct 2 and 3. So don't consider any variable which is touching more than one construct, because it appears 2 times. So this can create the correlation between the independent variable unnecessarily. It can create overlap between the variables. Look, why are we doing principal component analysis? Because we want to condense the variables. But if there is a one variable which is touching more than one construct, the problem still remains. So that is the reason that we don't take any variable which is touching. We want very pure constructs. If there is an X variable in a construct, it shouldn't go to the next construct. So we are within the principal component analysis, we wear the lenses to exclude. So it's very exclusionist approach. Try to exclude as many as unnecessary variable you can, so that very pure variables are left at the bottom. That is the idea. Santu, you have a question?
Yeah, I was thinking that the linear one we made before, it didn't matter in that one.
No.
Actually, it doesn't matter at all because they were not significant.
Yeah. But we haven't seen this. We haven't done the regression analysis yet in this case. Look, in the regression analysis, we take variables and do regression. Here, we take variables, we filter in, filter out, and then we do regression. So at this stage, we are only filtering in and filtering out. So we're not doing regression at all yet. It means that, I write it down before I forget. In the first construct, 1, we have OPR and PE, yeah? Don't care about the sign, it doesn't matter. And this, I can call it, so OPR and PE. In the second construct, we have what? We have innovativeness and D2E. And in the third construct, basically we have only one variable, which is FTSE 100 return. So it's an index return. I was assuming that P2E ratio would be in the market variable, but it's basically loading in the accounting variable. And I'm not surprised, because in the price to earning ratio, your price is coming from the stock market, but the earning is coming from the accounting data. So this variable is a kind of hybrid variable. So I can say that my first construct is including OPR, operating profit ratio, and the price to earning ratio. Are you with me? And the second construct is my organizational construct, which includes innovation and debt to equity ratio. And the third construct is only one variable, which is the company's, the index return. All right. So out of how many variables we had in the beginning? 7. 7 independent variables. And how many we have now? 1, 2, 3, 4, 5, 6, 7. And how many we have now? We have 5 variables. Yeah? Do we have 5 variables actually? We have OPR and PE representing the first construct. We have innovativeness and innovativeness and DE, the second construct, and the index return third. So we are from 7, we are reduced to 5 basically. Isn't it a good thing? We are throwing the unnecessary variable out. Now the first job is done. The first job is done. Now I come to Santu, what you said, that now we do regression, right? The question is that how you convert variable into construct. Very easy. We go to transform. Can you see transform here? Right? Transform, compute a variable. I repeat, transform, compute a variable. I compute it. My first construct is accounting performance. So let's call it accounting performance. Don't give the space. Accounting performance. And that included what? That includes OPR and PE. And what I do here, I can see that there are some functions like in Excel, there are statistical functions, and in statistics we have the mean. So I click mean and it gives me 2 values separated by comma. The first value is my OPR and the second value is P to E. So PE, yeah. Do you remember that in the first construct, in the first number 1, there were 2 variables loading, and those variables were operating profit ratio and price to earning ratio. So what I do, I combine them into one and take the average of the 2. Like simple we do that, okay, fine, three people, 3 marks, 3 courses marks, okay, take the average. And I call it accounting performance and I click OK. Yeah, and when I click OK, see what? Look, I go to my variables view and here I have accounting performance. It automatically, if you guys can't see, I can show it to you. And then we have the accounting performance automatically appears here. Okay. Then I go to the next construct, transform, compute variable. The second factor is called organizational. So I call it organizational thing, whatever. Organizational or organizational construct, okay? Construct. And here I take the average of D to E, because that's what it says, D to E. And the second variable was innovativeness. And I take innovativeness here. So 2 variables make 1 construct, 2 variables, D to E and innovativeness make organizational construct. And I click OK. And once I click OK, I can see that in my spreadsheet, in my SPSS sheet, I can see a variable called organizational construct. And then the third variable is left, which is the index return, basically. So either I take index return or rename it. I think I would rather rename it. So once again, I compute variable. and I call it market performance. So I call it market performance. And here, because it's not an average, it's only a single solitary variable, so I simply take it and rename it FTSE 100 return. So I rename it and click OK. Okay. Now, and when I check my variable, it shows me now 3 constructs: accounting performance, organizational construct, and market performance. So from 7 variables, we are reduced to 3 variables. So we have basically filtered, either we filtered them out, either we got rid of them, or we combined them. Either way, from 7 to 3. So we are more condensed. I know it's a bit, I think, I wish we had computers here, but I think when you do by yourself, and if you need my help again, of course, I would be available. We can do it all over again if you want. But I think once you watch the video, it will not be so complicated, believe me. Okay, now, our job is done, Santu. Now I come back to your point. We have the independent variable firm stock return, yeah? And now we have 3 independent factors. Sorry, we had the dependent variable. Sorry, I said other way around. We have one dependent variable, and its name is the company's stock return. But we have 3 independent constructs. The construct 1, accounting performance; construct 2, organizational construct; and the third is the market performance.
I want to argue with you about one thing.
Mm-hmm.
We're measuring stock market.
Yeah.
And we took out revenue, which is quite critical measure of firms' performance.
That's true.
I think it's this kind of distrust that it doesn't.
Well, if you notice now in our construct, 3 construct, there's no revenue. Revenue is filtered out.
Yeah, which I think is wrong.
Which is wrong. See, the absolute size of the revenue doesn't justify the stock price return. But
Quite important indicator.
no, wait a sec. If the absolute amount of revenue would push the stock return up, then all the big companies should have always high stock return, and the small companies should have always low stock return. So remember, we have ignored the absolute size of revenue.
Doesn't this more look like the trends that factor more than?
Yeah. So it could be possible that when you do the similar research for American companies, maybe revenue is an important factor. We don't know. In theory, revenue does make an impact. And this we study in the review of literature, by the way. But when we test that literature hypothesis in our empirical analysis, it's not significant. What can we do? Okay, so it means that our results are contrary to the theory. The theory does say that the more rich you are, more revenue you have, you send very good signals in the market, and the stock price would be favorable. But it doesn't happen in our case. What can we do? Yeah. So your results will not always be in conjunction with the theory. Yeah. All right. Now things become simple. How things become simple? Because now we only do the regression, basically. So what we do here, how do we do regression, by the way? We do analyze, regression, and linear regression. Remember, we started our discussion today from this point: regression, analyze, regression, and linear regression. And our firm stock return is by default dependent variable, because in the beginning we took it as a so it's still there basically. And then all of the variables I don't like them anymore, and I send them back. And then I only pick up our 3 constructs. That's it. Look at the phenomenon. We had the original variables, which we don't take them anymore. And then we make some constructs. 1, 2, 3. And now these constructs would be here. Right? Okay. So we are not using the original variables, we are using the constructs. And statistics, estimate, confidence level, collinearity, Durbin-Watson, they should be as before, model fit. I think we don't have to do anything because, and the plots, no, we do nothing here. Save, we still have the unstandardized value, it's fine, no problem. Nothing, I don't think we need to make any change, and let's click OK. And see what do we get. Yeah. And guess what we get? Once again, we find that our R square is 5.9%. Yeah, remember? Durbin-Watson test. Actually, did I go that far actually? Or let me see. Yeah, it's fine. Yeah. So our R square is 5.9%. Durbin-Watson test is beautiful, very close to 2. We liked it to be between 1.75 and 2.25, and it's perfectly, very, very middle of the middle. F, significant at 10%, all good. Coefficients, basically we have only one construct, which is our stock return, which is significant. Accounting performance and the organizational constructs play no role at all. Our VIF, it's the most optimum if it is 1, which it is. We can go even up to 3, 4, 5, but because it's less is better, and one is the least, 1 is the best. So we don't need anything else, I think. The other constructs are maybe important in theory, but not in our case. This is not far away from being significant because it's 0.13, but it's still, I will not take it because if it was 0.10, could have been fine, but because it's 0.13, and nothing less than 90% confidence is accepted. This is 87%, but still I will not take it. And then nothing else we see, basically. So our overall conclusion is that out of all the 3 constructs that we created, the market performance is the best construct. And this is what we do. I'm not going to compare that which technique is better. In my own research, I personally use multivariate regression analysis a lot. But recently I started using this PCA as well. But that's it. We have found one construct useful. The other 2 constructs are not so good. The only difference between regression and PCA is that in regression, we take the variables straight away and then we analyze them in regression. In the PCA, we take the variables, we filter out, we filter in, and then we combine variables, make constructs, and then do regression. That's it. Nothing else, nothing more, nothing less. So that's everything for today, basically. Okay, I know you have to do it by yourself to get better idea. But once you have your own data, okay, if you want, I can give you more dummy data if you want. You can also generate random numbers with the help of SPSS and Excel, okay? And you should try your hand on it by yourself, then you'll have better idea. But what I'm trying to do is that when you guys start writing your thesis in my track, most likely the topic would be quantitative based research, and then you need to use these techniques, okay? Even then I would help you, because normally what I do is that when my students get the data, then I book one time with them, 3-4 hours, and then we sit together and do the analysis together, because I don't want them to be lost. It never happened that my student has been doing SPSS by himself, herself, alone. Well, if you're living in Canada or elsewhere, it's a different story. But if you are in Finland, then normally I always book a time slot with them that we do sit together, and I give them more personalized coaching then again. But if you already are trained in it, then it's the icing on the cake. It's good for me. It saves my time and energy. Okay? So please go through it, and if you have a doubt or any confusion, we will continue next week also. Okay? Next week, I plan to have a shorter session, not for 2 hours, maybe 1 hour. And it could be possible that I give you some assignment to do by yourself. So wait for my messages in discussion forum. All right, thank you very much. I know it's a bit hard, it's a bit technical, but I'm so happy that you guys been so patient, and it seems that you have gained something in this workshop. Thank you very much, and see you next week, hopefully. There's a bit of chance that we don't meet next week. There's a little bit of chance that we don't see in the classroom, but in that case, I would inform you. If you don't hear anything from me, no message, then come as usual.